Hey guys, gonna teach you guys a lesson on adding and subtracting polynomials. It's gonna be a review mainly, but we gotta front load with some vocabulary. Now, it's essential that you guys know this vocabulary because it will be on the assessments, quizzes, tests that will be coming up in the future. To start off, we're gonna talk about a term called a monomial. A monomial is just basically a number, a variable, or a product of a number of one or more variables linked together. They're basically terms that are not going to be added and subtracted together. So examples would be like 12, which is a constant standing by itself, y negative 5x squared, y, or c divided by 3. Now you may be wondering, well, you said there's no adding and subtracting, then why is there a minus sign right over here? That's actually a negative sign. So it's denoting that the monomial is a negative term. So it is still considered a monomial. There's no adding and subtracting of terms together. Now, the next part is talking about the degree of a monomial. The degree of a monomial is the sum of the exponents and its variables. Sounds complicated, but pretty simple. Let me go over a couple examples. So if I have 2 over 3x, that's a monomial. And they're asking you, hey, what is the degree of the monomial? Well, all you have to do is figure out, well, what's my exponent? And you're taught before that there's an invisible exponent right over here. So in this case, my degree would just be 1. As simple as that. Now, what happens if they give you some extra terms? So let's say, not extra terms, but more variables, 7x squared, y to the third. And they say, hey, what's the degree of this monomial? All you need to do is just add up the exponents. So I have my 2 and my 3. So 2 plus 3, that's going to get me 5. So my degree is going to be 5, right? What happens if they give you just a negative 4? Negative 4. Well, there aren't any variables attached to this, and because there's no variables attached to this, your degree of any constant is gonna be 0. So make sure you guys replay this if you need to understand what is a monomial and how to go ahead and determine how to define the degree of a monomial. Extending what we know regarding monomials, a polynomial is basically a sum of one or more monomials. So I know I just mentioned some, but it can include subtraction as well. So some examples of polynomials are, let's say I got 3x squared plus 4x. See how it's separated by a plus sign. Or I can have negative 5y to the third minus 4y minus 6, right? They're separated by a minus sign. Or I can even say 3z to the fifth minus 15z plus 9. Those are examples of polynomials because they are a sum, or you can include adding, subtracting, of one or more polynomials. Same idea as before, is that we need to go ahead and find the degree of a polynomial. And it's essential that we find the degree of a polynomial because that's going to go ahead and tell us what type or how to name the actual polynomial. So for the very first thing is that if we're going to go ahead and name the degree of a polynomial, we need to find the highest exponent that exists in one of the monomials. So if I have, going back to the original problem, 3x squared plus 4x, and they ask me, hey, what's the degree of the polynomial? Do not add up all the exponents that exist because these are one or more monomials. What you have to do is look at your monomials and find out which one has the highest exponent. It just happens to be this one right over here. So my degree is going to be 2. Using the example from above, if I have negative 5y cubed minus 4y minus 6, my degree for this one is going to be existing in this monomial, and the degree will be 3. Again, in a polynomial where they're separated by addition or subtraction, you don't want to add up any of the exponents. And then the last one, if I have 3z to the 5th minus 15z plus 9, the degree of this polynomial existing right over here is going to be 5. Again, do not add up the exponents at all. So in all polynomials, the information that exists within the polynomial can be named using the degree, which was mentioned just earlier, and then we can also name it using the terms. We'll start off with naming it using the degree. So in a polynomial, let's give examples. Let's go 7x plus 4. So we said that to find the degree is we need to hunt for the term that has the variable with the largest exponent. So in this case, my largest exponent will exist with the x because that's the only term with the x. So my degree is going to be 1. And because my degree is 1, this is going to be considered a linear function. You can name it a linear equation, all right? So get this down. Now, the next one we can go ahead and bring up is the increasing of the exponent. So let's go 3x squared plus 2x plus 1. So the degree exists right over here. So my degree is going to be 2. And because my degree is 2, this is considered a quadratic equation. If I have a polynomial with a degree of 3, so that happens to be the only term, hint, it's a monomial, not separated by an addition or subtraction sign. So my degree is 3, and because my degree is 3, it is going to be considered a cubic equation or cubic function. If it happens to increase from there, right, anything past 3, so if I have 9x to the 4th plus 11x, my degree is still the same. The largest one is right over here, is going to be 4, but there's not really any fancy name for it, so you can say to the 4th degree, right? What happens if you have a constant, let's say 5? Well, my degree is 0 because there are no variables in here. So therefore, it is going to be a constant. A number that stands alone is always going to be a constant. All right, so we hit naming all the equations using the degree. So now we need to talk about how to name them using the number of terms. So there's actually going to go ahead and be a separate little thing that we have to count. So I'm going to change the color for this one. Let's use orange, right? Go Oilers. So for the very first top one, which we're talking about 7x plus 4, right? We count the number of terms. Remember, the number of terms are separated by plus and minus sign. So that's 1, 2. So number of terms. So number of terms, right? Number of terms. So this is going to be 2 terms. And when you go ahead and have a polynomial with 2 terms, this is considered a binomial, right? Bi, 2, like bicycle. The next one is 3x squared plus 2x plus y. So I have 1 term, 2 terms, 3 terms. So I have number of terms being 3. Okay, let's erase that. That's ugly, right? So the number of terms for this one is going to be 3. And 3 terms would be considered a trinomial. trinomial. If it is a term with only one, right? That's only one for this one. This is a monomial. If it is doing a little review, I got 1, 2. So this is two terms right over here. Going back to what we talked about up on the very top, two terms would be a binomial. And if it is a constant that stands alone, that's one term, that's one right here, this is going to be a monomial. Okay, so it won't get any larger than trinomials in this case, but just make sure you're aware of how to name using the degree and name using the number of terms. All right, time to hit the home stretch of our lesson, which is adding and subtracting polynomials. So adding, subtracting polynomials, one thing I can't stress enough is I know you're gonna look back from the previous units and there were all these exponent rules, but when it comes to adding and subtracting polynomials, do not mess with the exponents. And what I mean is that don't attempt to combine the exponents. All you're doing in this first part of the unit is just combining like terms. Again, do not mess with the exponents. So looking at some example problems, let's start with problems with adding and subtracting. So let's try a problem that looks like this. So I have 4x squared plus 6x plus 7 plus 2x squared minus 9x plus 1. All right, so adding's really simple. There's a really straightforward process to this. Just combine like terms. So what you're looking at in this problem are a set of polynomials that is being added horizontally. All you need to do is combine like terms. So let's switch to blue. So my very first set of terms, well, I'm gonna start with the 4x squared. And I'm gonna look for a monomial that has the same degree. So right over here, 2x squared, so 4 plus the 2x squared, that's gonna be 6x squared. And then again, I'm gonna square this one, 6x. Well, that looks like that negative 9x. Now, what happens is that people just write 9x, but you need to include the minus sign. And minus and negative can be interchangeable. So you can go ahead and say that's a negative 9x. So 6 plus the negative 9x, that's going to be minus 3x. And then the last one, I'll triangle it, right, are these two terms. So 7 plus the 1, that's going to be 8. That's it. You're combining like terms. And note that I did not mess with the exponents. As simple as that. As simple as that. Now, you have another case. They're gonna go ahead and write it horizontally. What I mean horizontally, it's kind of like old school addition that you might have done in elementary school, but they're just stacking it up. So another example is going to be, let's say, let's go 12 m squared plus 4, and then I'm gonna write plus right over here, and I have 8m squared plus 5. So this one, they're stacking it up. So you can actually rewrite the very first one. If it looked kind of overwhelming, you could have rewrote it as 4x squared plus 6x plus 7 plus the 2x squared minus 9x plus 1, and went ahead and add straight down. So you have flexibility with this stuff. So going right back to this problem right over here, add straight down. So I have 12m squared plus the 8m squared. Make sure that they are the exact same term, that you can combine them. So that's going to be 20m squared. And then the 4 plus the 5, that's going to be 9. Right? As simple as that. You're done. Do not attempt to solve for the variable. You're just combining like terms. Combining like terms. Take a minute and write this problem down, right? And see if you guys can figure it out. So I have t squared minus 6, and then I have 3t squared plus 11. All right, we're adding these together. Go ahead, pause the video, try this problem out. All right, hopefully you pause it, and then you press play after trying the problem. Let's solve this one. So going to this problem, remember, I have an invisible 1 right over here, so I'm going to add straight down. So that's going to be 4t squared. And adding straight down to these two, negative 6 plus 11, that's going to be positive 5. All right, so adding polynomials is pretty easy. Now, for subtracting polynomials, I don't want you guys to go ahead and think, it's exactly the same as adding polynomials, because there's one little trick. But the one main idea I want you to take away from this is that you're not going to mess with any of the exponents. You're still going to be subtracting terms that are alike. Now, with subtracting, it can be a little bit tricky, but I'm going to go ahead and show you guys a clear way to do it. You don't have to go ahead and do my way. If you find another way to subtract polynomials to be a lot easier and quicker to do, try it out. Now, what I do is with subtracting, just to make sure that I don't mess up on anything, is that I go ahead and try to get rid of this little negative 1 right over here. It's a minus sign. So what I'm going to do is I'm going to keep the very first set of parentheses. So note, I'm just jotting down whatever is inside the very first set of parentheses. And for this negative 1, what I want you to do, or think of it, is that you're distributing that negative 1 to each one, or you're flipping the signs of each term inside the second set of parentheses. So that becomes negative x cubed plus 8x squared minus 11. So if you're subtracting, I just go ahead and flip the signs of the second set of parentheses, or if it leads with a minus, I just flip the signs. And then afterwards, I can go ahead and combine like terms. So in this case, when I do this, I have 2x cubed minus x cubed. So that's going to be 1x to the third. And then I have 5x squared plus 8x squared. That's plus 13x squared. Now, this term doesn't have anything that matches up, because what people think it's going to match up with this, but that doesn't have an x, so I'm going to write minus 3x minus 11. Note, I did not mess with the exponents at all. So a little trick for the subtracting polynomials: get rid of the minus sign. You don't really need it. All right, let's try the other way where it's written horizontally. So if I have a problem that looks like this, so I have v cubed plus 6v squared minus v, and then I have a minus right here, right? And then I'm going to have 9v to the third minus 7v squared plus 3v. I'm going to do the same thing. I'm going to get rid of that minus sign that's looming right out of here. So moving here, so I'm going to rewrite my terms. I got v cubed, keep my very first set of parentheses, all the terms inside, they don't flip or anything, minus v. And then I'm going to go ahead and flip the terms on the very bottom. So I'm going to have a little plus sign. So that becomes negative 9v to the third plus 7v squared minus 3v. So I'm just going to go ahead and combine terms going straight down. Note there's an invisible 1 right over here. That becomes negative 8v to the third plus 13v squared. And then the last one, another invisible 1 right over here, minus 4v. Minus 4v. So you can go ahead and do the same trick that I just brought up to help you solve these polynomials a lot easier. So, you can do it vertically or horizontally. It's the same exact thing. So try this problem out on your own. Once you copy down this problem, pause the video, see if you can do it without my assistance. So let's do 30d to the third minus 29d squared minus 3d minus parentheses 2d to the third plus d to the second. Okay. Pause real quick. All right. Hopefully you paused. Tried this out on your own. So for this problem, again, note that there is a minus sign right over here. So I'm going to get rid of that. So I have 30d to the third, 29d squared minus 3d, right? Note I'm not messing anything in the very first set of parentheses. And then I have, when I flip the second one, because I'm flipping everything in here, that becomes minus 2d to the third minus d squared. Combine all my terms. So I have this and this, the 30d cubed, and minus 2d cubed. So that becomes 28d to the third. This and this combines, the negative 29d squared and a minus d squared. That becomes minus 30d squared. And then this right here becomes minus 3d because that's the only term that's left and can't be combined for anything else. So hopefully you guys found this video informative. If you need help, reach out to us. Take care. Bye.